All right, for this one, we're going to give you the quadratic equation, and you're going to have to try and find all those pieces from that. So a little reverse from giving you the actual graph or some coordinates, but very, very similar. So let's find x-intercepts first. Remember, x-intercepts are when the y equals 0. So it's like this thing right here equals 0. The only way the left side is going to equal 0 if there's something on the right side, some x value that will make the right side 0. So again, it's a flip-flop of that. I got to think about, okay, what would I plug in for x to make the parentheses 0? The only thing I could plug in for x that when I subtract 1 from it to make it 0 would be 1. So one of my x-intercepts is at 1, comma 0. And if you need to, plug x in as 1 for both of these. See if that all the computations become 0. It'll be verified. Other one, though, we do have two x-intercepts in this one. I have to think of an x, then when I add 7 will equal 0. So the other one in this is negative 7, comma 0. Now what I might do here is actually plot this, do a rough sketch, just so you can see where these coordinates are, and kind of get the spacing. I think it helps for the next steps too. That right here at 1, you're going to have your x-intercept, negative 1, 2, 3, 4, 5, 6, negative 7. You're going to have another x-intercept right on that x-axis where y would equal 0. The second part we want to find, we think is nicely tied to the x-intercepts, is the line of symmetry. The line of symmetry is always halfway between your x-intercepts. If you can judge it, you can judge it, but if not, there is a way to find halfway between these. If I find the average between the x's, a 1 plus a negative 7, and divide it by 2, that will find me the x-coordinate of this line of symmetry. So a 1 plus a negative 7 is a negative 6, divided by 2, which is negative 3. And if you look here at negative 3, that looks to be about halfway between that 1 and negative 7. Now that's all good that it finds us this line of symmetry, but all we really know, again, we could have fat parabolas, we could have skinny parabolas, they could have really high maxes and mins, but we got to find exactly where that max or min is. The nice thing about it, the max or min is always on the line of symmetry. Now what I mean by that is it's somewhere here, it's maybe up top, maybe it's down below, but up top or down below is trying to find the y value of that max or min, because I know the x. You know the x is negative 3. I got to figure out what's the y with that. Well, that sounds like I'm going to use the function. I know the x. I got to figure out the y. That's what functions do for us. So really what I'm finding then, I'm going to plug in my line of symmetry, f of negative 3. That's going to be 2 times negative 3 minus 1. There's an x. I got to plug in negative 3. There's another x. I got to plug in a negative 3 plus 7. Now computation. So f of negative 3, 2. A negative 3 minus a 1 is a negative 4. A negative 3 plus a 7 is a positive 4. So a 2 times a negative 4 is a negative 8. Times a 4. Negative 8 times a 4 is a whole big negative 32. So we have a pretty low minimum in this one. But I do have a coordinate. This is my x, this is my y. I plugged in x to find y. The min is going to be at negative 3, comma, negative 32. Way down in that line of symmetry. Another reason that I can think, let's just kind of estimate it here, negative 32 is way down here. There's my minimum. Another reason I know was going to be a minimum is all about that a value. So if you're going to decide between min or max, it's something we haven't hit a ton, kind of review topic from one, but if it's going to be a minimum, that means it has to open up. That means your a value is positive, or you have a positive a value. If it's going to have a maximum, you just got to think that, well, then it would have to open down, kind of have that frowny face. That would have a negative a value. So positive a value is going to open up. You're going to have a minimum. A negative a value is frowny. You're sad. You got a frown. That will have a maximum. So my minimum in this case is at negative 3, negative 32. The last point we would want you to find is the y-intercept. And what helps us to understand what a y-intercept is that, okay, anything that crosses this line, this y-axis here, is a y-intercept. These coordinates might be 0, 2, 0, 4, 0, 7. But you notice by saying those, 0, 4, 0, 7, 0, negative 10, it tells me what x is. X is always 0 on a y-intercept. So plug in x is 0. Or it's like we're finding f of 0. 2 times 0 minus 1, 0 plus 7. This is always your x inside the parentheses. It's always your x, so plug it in where those other x's are. So f of 0 is 2 times negative 1 times 7. F of 0 then equals 2 times negative 1 is negative 2 times 7. So f of 0 equals negative 14. As a coordinate, this is your x, this is your y. 0, comma, negative 14. And then I look at my graph. Does that make sense? Well, if that's negative 32, not exactly halfway, but about halfway up, we'll say that's our negative 14. So on a tablet, be nice with me. This might look a little sketchy. Get it? But don't ching. It is just a sketch, but this is what my parabola should look like. It goes through those 4 points, 4 key points that we're finding, 2 x-intercepts, a y-intercept, and a max or min. So I hope this helps. It's really important to know, okay, x-intercepts, this is what I do. Line of symmetry, how can I use that? So, read over, check over again those little rules, but here's a good example. And try. Keep practicing. Good luck.